Method is if you treat the numerator as one single unit and we combine it and rewrite it as one fraction, our LCD is going to be an x squared and a y squared. So there's our LCD. So what we'll do is we'll take the numerator of our first fraction, which is 1, times the LCD factor that's missing from its denominator. So between the x squared, y squared, what's missing from this denominator? Just the y squared, right? Then minus 1, the next fraction's numerator, times what LCD factor is missing from this denominator? It's missing the x squared. So there's our numerator written as a single fraction. We're going to do the same thing with our denominator here. We're going to write it as a single fraction. We have an LCD of x cubed, y cubed. And so when we take our first fraction's numerator 1 times the missing LCD factor, it's missing y cubed, plus the next fraction's numerator 1 times the missing LCD factor, which is x cubed. Okay, so here is your fraction, complex fraction, written as a single fraction divided by another fraction. So what we can do here is factor each of these. So when I take my numerator here, I get y squared minus x squared. It gives me the factors y plus x times y minus x. And that's all over x squared, y squared. And in my denominator here, when I simplify this, my x cubed, y cubed stays. But in the top I have the sum of cubes. The sum of cubes has two factors. The sum of the terms being cubed, y plus x, and then times the first term squared. Opposite the product of these terms, y times x is minus xy, plus the last term squared, in this case x squared. Okay, so my final steps here are to rewrite this, invert, and multiply. So now we still have this fraction, but instead of it being treated as a fraction, we're going to multiply by the reciprocal. So x cubed, y cubed gets moved from the denominator to the numerator. And then this y plus x times y squared minus xy plus x squared. Okay, and so now when I look at these, my y plus x's cancel, my x squared cancels with 2 of these, my y squareds cancel with 2 of these. And so in the top, what I'm looking at is I have an xy. Here I'm going to go ahead and reorder my terms. So I'm going to reorder this as a negative x plus a y, and I'm going to factor out a negative from this. I'm going to put my negative out front, changes that to a positive x and a minus y. So there's my new numerator. And then the denominator, I'm just going to reorder my terms in standard form. So I'm writing the x squared first, minus xy plus y squared. So here is my fraction in simplified form. There's nothing that can cancel out from this any longer. So when I look at my domain restrictions, I can see here, since I inverted and multiplied, I take all canceled factors from this set plus the remaining factors from the numerator of this inverted fraction. And so I see that x can't be a 0, y can't be a 0, x can't be a negative y. Those are all my restrictions. So x not equal to negative y and 0, and then y not equal to 0. So those are my additional domain restrictions. Okay. Now, if you thought about solving this using the second method, okay, the second method means now you're going to treat it as an entire fraction multiplied by the LCD of everything, all the fractions involved. You need an x squared, y squared, x cubed, so the minimum number of x's that I need are 3, and y cubed, same thing, minimum number of 3. So if you're going to use the LCD method, here's your LCD. Write that number over itself, and then just work in the numerator to start with. When you distribute through, 2 of the x's cancel, leaving an xy squared, or xy cubed. Then minus the numerator, the second fraction's numerator 1 times the missing LCD factor. In this case, it's missing as the x cubed y. And then move down to the denominator, do the same thing, distribute that through. When you distribute this through, In the first term, you're left with a y cubed, plus the second term, you're left with x cubed. Okay, so if you're going to set it up in this manner, what you can factor out in the numerator is xy. When you do that, you're left with y squared minus x squared. Okay, and then in the denominator, you have the difference of these two cubes. I'm going to go ahead and rewrite this, x cubed plus y cubed. And then up here, I'm also going to go ahead and come back. I'm going to reorder this. This was a negative x squared and then a plus y squared. If I take out this negative sign, I'm going to take the negative out. We change this sign to a positive and this sign to a negative. And now what you can do is factor each of these independently. So we have the difference of squares, x plus y, x minus y. Here the sum of cubes, so it's x plus y times x squared minus xy plus y squared. And you can see here the x plus y's cancel, and you're left with the exact same answer that we got using the first method. So it doesn't matter which method you choose. The one thing that you would have to take into consideration, though, is when you find your domain restrictions, you see here that x can't be negative y, but you'd have to go back into the original form to find the other exclusions for x and y, and that's just the nature of that second method.